Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 12 maths, arithmetic sequence, and sum to end terms of an arithmetic sequence. And we're going to be looking at a question from the February-March 2016 paper 1. If we go quickly and look at the work schedule, this particular question should cover the following points. Well, let's go read the question first. We'll come back here in a moment. It says, consider the arithmetic sequence. So you are given that this is an arithmetic sequence which has a second term equals to 8. So therefore T2 equals to 8 and the fifth term is equal to 10. So T5 is equal to 10. It says determine the common difference of the sequence. Write down the sum of the first 50 terms of the sequence using sigma notation. And also it says determine the sum of the first 50 terms of this sequence. So if we go back to the work schedule, it should cover the following: sigma notation and also the sum to end terms of an arithmetic sequence, which is this point here, and also arithmetic sequences. Don't forget that in previous videos we've covered geometric and quadratic sequences as well as sum to infinity, but we will be covering it in further videos. So let's go back to the question. So therefore the first thing that we need to do is sift out the information as we have done. So the answer for 2.2.1 would start as follows. They tell us that T2 is equal to 8. So if T2 equals to 8, so what does that mean? It means that 8 must equal to A plus n minus 1. Now don't forget that n will be 2, so that will be 2 minus 1, which is going to be 1 times d, which is d. Which formula am I using? Tn equals to A plus n minus 1 times d. And this is to find the general term of an arithmetic sequence. So therefore, for T2, 2 minus 1 is 1, 1 times d is d, and they told me that the second term is equal to 8. So therefore, that's going to be equation 1. The second equation I'll get from, they tell me that the fifth term is equal to 10. So therefore, I'll say 10 equals to, once again, A. I'm using this formula, the general term of an arithmetic sequence once again. So that will be A plus what they told me, the fifth term, so that will be 5 minus 1 is 4 times d is 4d, so that will be plus 4d, and that will be called equation 2. Now if I look carefully, I've got simultaneous equations both. So as you can see, I've got linear equations, 2 of them, and simultaneous equations. So therefore, easiest way for me to get rid of one variable would be to say equation 2 minus equation 1. Equation 2 minus equation 1 would yield the following results. 10 minus 8 is equal to 2. A minus A, the A cancels off, and 4d minus d is 3d. Therefore, d will equals to 2 over 3. Now, I can solve for A. Now, although they don't ask me for that, I think they just ask me for the common difference. And I've solved the question, but let's find A one time. So we'll substitute in equation 1 or 2. Let's substitute in equation 1. And by doing that, we'll get 8 equals to A plus 2 over 3. And we'll get A equals to 8 minus 2 over 3 will give us 8 minus 2 over 3. Let's do that again. There we go. 2 over 3. And we got 22 over 3. So A is going to be 22 over 3. Let's look at the next question. In the next question, we have write down the sum of the first 50 terms of the sequence in sigma notation. Now, sigma notation works as follows. So for 2.2.2, the symbol for sigma notation is this symbol here. And remember that we have the bottom. That's where we're going to start. And the end is where we're going to finish. So they want the sum of the first 50 terms. So therefore, we're going to make n starting from 1 and it's going to go all the way up to 50. Now what do we need to do? Well, the formula has to go here. So we need the formula, and there's the equation that we're going to be using for the formula. So it was actually very wise for me to solve for both D and A. Alright, let's look at 2.2.2. So for 2.2.2, I first need to get the formula. So Tn equals to A plus n minus 1 times D equals to, so what do I have here? 22 over 3 plus n minus 1, and my difference is 2 over 3. So that's my formula. So to write in sigma notation will be as follows. There's my symbol for sigma notation, and I'm going to say n is going to start from 1 and it's going to go to 50 terms, and here it's going to be 22 over 3 plus n minus 1 times 2 over 3. If I want, I can just put that in brackets like so. Alright, so that's my solution. It's going to start from 1 and go to 50. Remember to calculate the number of terms using sigma notation. It's top minus bottom plus 1. So 50 minus 1 plus 1 is 50 terms. Let's look at the next question. In the next question it says, determine the sum of the first 50 terms of this sequence. So we're going to be using the formula that I showed you a little bit earlier on. Remember, there's two formulas that we can use. Now the formula that I'm going to use is n over 2 into 2a plus n minus 1 times d. Now this is the formula that we're going to use. The other formula that we are given, for example, Sn equals to n over 2 into a plus l. Now that's only if the last term is given. Alright, otherwise we'll just use this formula. So therefore S 50, the sum of the first 50 terms will be 50 over 2 times a, what's my first term? That's here, 22 over 3. So let's put that in brackets here, 22 over 3 plus 50 minus 1 times, and there's my difference up here, 2 over 3. I'm going to put that in the calculator. 2 over 3 equals 2. So let's go put that in. Okay, learners, so let's have a look. So here we got 50 over 2, and that's going to be 2 into 22 over 3 plus 50 minus 1. 50 minus 1. We could have just written 49, right? But anyway, let's put it as it is. Times 2 over 3. 2 over 3. Let's close the bracket up there. 3,550 over 3. 3,550 over 3. So therefore the sum of the first 50 terms will be 3,550 over 3. That is, if you haven't subscribed already, subscribe to JL. That's my YouTube channel. You can also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos on my website, which is jlmaths.com. And I'll catch you in the next video.